Hi students, problem number 6. A system has two charges QA equal to 2.5 into 10 power minus 7 coulomb and QB equal to minus 2.5 into 10 power minus 7 coulomb. Located at point A having coordinates 0, 0, minus 5 centimeter and point B having coordinates 0, 0, plus 15 centimeter respectively. Okay, what is the total charge and electric dipole moment of the system? So the Cartesian coordinates will be like this: x, y and z axis taken mutually perpendicular to each other in the anti-clockwise direction. So I have taken this is the x axis, this is y axis, and this is the z axis in the right hand, okay, screw rule, that is anti-clockwise direction. So two charges are located having the coordinates. X coordinate of A and B is 0. Y coordinates of A and B also is 0. So along the z axis only, the two charges are located, is it not? Now you see here the coordinate A, z coordinate is minus 15 centimeter. So this is point A. So this is minus 15 centimeter, and at point B it is plus 15 centimeter, So a charge of 2.5 into 10 power minus 7 coulomb is located at A, and a charge of minus 2.5 into 10 power minus 7 coulomb is located at B. So from the origin, the distance of A is 15 centimeter, and the distance of B from the origin is also 15 centimeter. Therefore, what is the total distance between the 2 points A and B? Only the distance equal to 15 plus 15, 30 centimeter. Is it not? So this arrangement of two equal and opposite charges separated by a small distance is going to act like a electric dipole. So here I will take the charge QA, okay, QA is equal to 2.5, okay, into 10 to the power of minus 7 coulomb, and the charge at B is QB is equal to minus 2.5 into 10 to the power of minus 7 coulomb. Now normally the distance between these two charges making a dipole is represented by the letter 2A. 2A is a symbol, is it not? So the distance 2A is now equal to 30 centimeter. So this is equal to 0.3 meter. Here only care should be taken. You should not take the symbol as a D or A. You have to take either 2D or 2A. Understand that? So and this is also minus 15 to plus 15. The distance of separation is 30 centimeter. Here only one point you will have to understand. So now what is asked first? The total charge is asked, is it not? So the total charge, one is positive, the other one is negative. They are equal in magnitude and opposite in polarity. Therefore the total charge Q is equal to QA plus QB, and this is equal to 2.5 into 10 power minus 7, okay, plus minus 2.5 into 10 power minus 7. So this is equal to what? 0. The net charge is 0. And electric dipole moment, okay. So how do you define the electric dipole moment? The electric dipole moment is defined as the product of what? The magnitude of one of the charges making the dipole and the distance between the two charges. So the magnitude of the electric dipole moment P is equal to Q multiplied by 2A. So what is one of the charges? The magnitude of one of the charges is taken as what? 2.5 into 10 to the power of minus 7 coulomb into the distance of separation between the two charges is 0.3 meter. So this is 0.3, and this is also equal to, you can you can write this as 2.5 multiplied by this 0.3 can be written as 3 into 10 power minus 1 into 10 power minus 7. So 2.5 into 3 is how much? It is 7.5. Is it not? This is 10 power minus 1 and this is 10 power minus 7. So this is 10 power minus 8. So this is 7.5 into 10 power minus 8. Charge is in coulomb, distance is in meter. Therefore, it is a coulomb into meter. It is not centimeter, it is coulomb into meter. So we can write the dipole moment. So this is the magnitude. Now, in which direction does the vector dipole moment will act? It will be always from the negative charge towards the positive charge. So it is from the negative charge means from B towards A. So this is the direction of the dipole moment vector. Okay, students. So the magnitude of the dipole moment and the direction P vector is along, okay, is along BA. Okay, along BA. I hope you must have understood well. Fine.